The history of wireless communication has been defined by speed. From the first voice calls to the streaming era, we have sought to move data faster and further. But as we stand on the threshold of the 6G era, the paradigm is shifting. It is no longer just about how fast we connect, but how intelligently our world communicates. In this new era, the network becomes more than a pipe for data. It becomes a perceptive, intelligent entity that senses the physical world. This is the vision of Integrated Sensing and Communication, or ISAC. It is the sixth sense of the 6G network. Imagine a network that doesn't just transmit data, but actually perceives its environment, seeing through obstacles that blind traditional cameras. This convergence is not just a feature, it is a fundamental requirement for the intelligent applications of tomorrow. The ITU has officially approved ISAC as one of the decisive usage scenarios for 6G networks, signaling a global shift in wireless strategy. To build this future, we must look under the hood at the core principles and breakthrough technologies that make 6G possible. It begins with the architecture. Conventional centralized towers are giving way to distributed MIMO, or DMIMO. By deploying a massive number of nodes that cooperate, DMIMO provides a new level of spatial diversity and high reliability. This ensures uniform service over the entire coverage area, eliminating the dead zones that plague current networks. Even in dense urban canyons, where signals are often blocked, the distributed framework ensures a line-of-sight link is almost always available. ISAC allows us to use the same hardware and spectrum for all these tasks, leading to incredible cost and energy efficiency. This setup yields a significant diversity gain, utilizing multiple uncorrelated observations to achieve high-precision sensing. Localization and sensing enhance the network's comprehension of its radio environment, simplifying backhaul and reducing overhead. By precisely controlling these reflections, RIS can reshape the wireless environment, creating virtual line-of-sight links where none existed before. With RIS, we can eliminate dead zones in our cities, ensuring that a connection is always available, even in the deepest urban canyons. Because RIS elements are passive and don't require power-hungry amplifiers, they offer a highly energy-efficient way to boost network performance. We are also adding physical flexibility to the antennas themselves. Movable antennas, or MAs, represent a breakthrough in spatial degrees of freedom. By dynamically adjusting their positions, MAs can exploit the full spatial diversity of the channel, significantly boosting capacity and reliability. The synergy between movable antennas and RIS is transformative. Together, they offer a massive boost in spatial degrees of freedom. This combination delivers a dramatic improvement in angular resolution, allowing the network to distinguish between closely spaced targets with ease. A related breakthrough is the Intelligent Rotatable Antenna, or IRA. These antennas don't just move, they rotate their radiation patterns. IRAs can flexibly rotate their boresight direction to align perfectly with users or targets, maximizing gain while suppressing interference. But how do we speak both communication and sensing in the same breath? This requires a revolution in waveform design. By optimizing the allocation of power across time, frequency, and beams, we can maximize performance for both functions. By optimizing the allocation of power across time, frequency, and beams, we can maximize performance for both functions. The challenge is managing the trade-offs between sensing resolution and communication throughput while maintaining ultra-low latency. All of this sensing data generates an immense computational load. 6G solves this with a multi-tier, cross-domain collaborative computing architecture. By balancing tasks between local nodes and central hubs, the network achieves the responsiveness needed for mission-critical operations. Consider a swarm of autonomous aerial vehicles. To fly safely and complete complex tasks, they must sense and communicate in a heartbeat. The hierarchical computing framework allows them to offload heavy calculations to the edge, enabling real-time autonomous flight. This scalability will power the emerging low-altitude economy, coordinating thousands of autonomous vehicles in our skies. One of the most powerful functions of ISAC is static environment reconstruction, or SER. The network uses reflected radio waves to map building layouts and environmental conditions, building a high-precision map of our physical world. Modern 6G systems use dual functional waveforms that simultaneously perform both tasks using a single unified signal. By optimizing the allocation of power across time, frequency, and beams, we can maximize performance for both functions. The challenge is managing the trade-offs between sensing resolution and communication throughput while maintaining ultra-low latency. All of this sensing data generates an immense computational load. 6G solves this with a multi-tier, cross-domain collaborative computing architecture. By balancing tasks between local nodes and central hubs, the network achieves the responsiveness needed for mission-critical operations. Consider a swarm of autonomous aerial vehicles. To fly safely and complete complex tasks, they must sense and communicate in a heartbeat. The hierarchical computing framework allows them to offload heavy calculations to the edge, enabling real-time autonomous flight. In the event of a task overload, the system can migrate workloads across domains, ensuring seamless operation and load balancing. One of the most powerful functions of ISAC is Static Environment Reconstruction, or SER. The network uses reflected radio waves to map building layouts and environmental conditions, building a high-precision map of our physical world. Then there is Dynamic Target Sensing, or DTS. This is where the network detects, estimates, and tracks moving objects in real time. DTS allows the 6G system to recognize categories of important targets, from vehicles to pedestrians, and predict their motion with extreme accuracy. The network can even sense the materials of objects through electromagnetic property sensing, or EMPS. By estimating electromagnetic coefficients, the network can identify materials, judge the ripeness of fruit, or even discover hazardous objects. The convergence of these technologies leads to the ultimate application of the 6G era, the creation of the digital twin, a living, breathing digital map that allows us to simulate, predict, and optimize reality itself, from smart factories to entire city grids. In this world, responsiveness is measured in milliseconds, enabling life-saving applications in autonomous transport and remote medicine. The journey towards 6G is more than just a technical evolution. It is the realization of a truly intelligent, perceptive, and interconnected world. The future is no longer just on the horizon, it is being sensed right now. Welcome to the era of the sixth sense. As we push further into the electromagnetic spectrum, the challenges of path loss and scattering become more acute at MM-wave and sub-THz frequencies. But with the high-gain beamforming of 6G, we can overcome these barriers, turning high-frequency spectrum into a vast highway for data and sensing. One of the fundamental shifts in 6G is our focus on the near-field region, where the curvature of the wavefront itself becomes a tool for precision. Processing these spherical waves allows the network to separate users at the same angle but different distances, a feat once considered impossible. Reconfigurable holographic surfaces take this a step further, manipulating the entire electromagnetic field distribution with sub-wavelength precision. We are exploring both reflective and transmissive metasurfaces, creating a world where every surface can actively steer and focus energy. Stacked Intelligent Metasurfaces, or SIM, act like a physical neural network, processing signals in the wave domain as they traverse multiple layers. This wave domain processing happens at the speed of light, providing incredible computational power with near-zero energy consumption. The challenge is managing the trade-offs between sensing resolution and communication throughput while maintaining ultra-low latency. This will enable a new kind of smart city, one that optimizes energy flow and connectivity based on real-time sensing data. Beyond solid surfaces, we are even exploring fluid antenna systems, where liquid meta-elements can flow and reshape themselves on demand. This allows for ultimate adaptability, as the antenna can change its physical properties in milliseconds to maintain the perfect connection. By combining 3D positioning and rotation, 6D movable antennas unlock the final degrees of freedom in signal control. The combination of intelligent rotatable and movable antennas provides a level of beam agility that will redefine the 6G transceiver. This extreme agility allows the network to precisely suppress interference in dense environments, boosting capacity for everyone. As sensing becomes ubiquitous, 6G is built with privacy at its core, using electromagnetic signatures to sense objects without capturing personal data. Specialized ISAC waveforms are being designed to be inherently secure, ensuring that sensing data is protected as it moves through the network. Physical layer security uses the complexity of the 6G environment to shield our data from eavesdroppers at the most fundamental level. The 6G network is designed to be infinitely scalable, with distributed protocols that allow for the seamless addition of millions of nodes. This scalability will power the emerging low-altitude economy, coordinating thousands of autonomous vehicles in our skies. With vertical 6G coverage, drones and air taxis will have constant, high-precision sensing and communication, regardless of their altitude. In disaster response, these systems will be life-saving, building real-time maps of areas that are too dangerous for human rescuers to enter. Using 6G radio waves, search and rescue teams can see through smoke and debris, locating survivors with centimeter-level precision. In the industrial world, 6G will enable a new level of automation, where machines interact and cooperate with near-zero latency. With real-time machine learning integrated into the network, industrial systems will optimize their own performance in milliseconds. Even our oceans and ports will become part of the 6G web, with marine management systems powered by integrated sensing. Environmental monitoring will become autonomous and ubiquitous, providing real-time data on the health of our planet's most critical ecosystems. In healthcare, 6G will enable the smart hospital, where patients are monitored wirelessly with medical-grade precision. With ultra-low latency and integrated sensing, remote robotic surgery will become a reality, bringing world-class care to everyone, everywhere. We are moving toward a future of seamless connectivity, where the network anticipates and adapts to our every need. Digital and physical realities will blend into one, creating a world of limitless information and immersive experience. This new era of connectivity will also play a critical role in our fight against climate change, optimizing energy and resources globally. By creating a truly efficient and intelligent world, 6G is the foundation for a sustainable future for all of humanity. The journey of 6G doesn't stop at Earth. It is the beginning of a truly interplanetary network, the foundation for the next frontier of exploration. The sixth sense is more than just a technology. It is a new way of seeing, understanding, and interacting with our universe. The future is no longer just on the horizon, it is being sensed right now. Welcome to the era of 6G. Welcome to the sixth sense. The path to 6G is being paved now through rigorous global standardization and groundbreaking research across the industry. With Release 19, the integration of sensing into the global wireless standard has officially begun, setting the stage for the 6G rollout. This is a truly global effort, a collaboration between scientists, engineers, and visionaries from every corner of the world. Prototype systems are already demonstrating the incredible power of ISAC, proving that the sixth sense is not a dream, but a reality in the making. These tests show precision measured in centimeters, a level of accuracy that will unlock entirely new categories of human achievement. The 6G vision is to bring gigabit connectivity and intelligent sensing to every person on the planet, regardless of their location. From the densest cities to the most remote villages, 6G will bridge the digital divide, providing the tools for a truly global education. This technological revolution will create an entirely new economy, powered by the data and intelligence of the 6G web. With real-time intelligent tutorship, the path to mastery will be open to everyone, creating a world of lifelong learners. Ultimately, 6G is not just about the technology, it is about enhancing the human experience and unlocking our full potential. We are entering an era of limitless creativity, where our physical and digital tools work in perfect harmony to bring our ideas to life. The network will become invisible, a fundamental and silent part of our world that empowers us without ever getting in our way. Our health and wellness will be monitored continuously and silently, providing a proactive approach to care that will double our quality of life. Your personal AI will be powered by the 6G web, providing you with perfect information and assistance wherever you go. The infrastructure of our world will become self-optimizing, responding to the needs of every citizen in real time. Cross-border collaboration will reach new heights, creating a truly global and interconnected society. The legacy of the 6G era will be a world that is more intelligent, more sustainable, and more connected than ever before. We will use the power of integrated sensing to explore the unknown, from the depths of our oceans to the farthest reaches of our solar system. 6G will be the nervous system of our interplanetary future, connecting us across the vast distances of space. The frontier is open, the technologies are here, and the future is waiting for us to sense it. Welcome to the 6G era. Welcome to the world of the sixth sense. The journey has just begun. The 6G era, Sensing the Future, an original production. Join us on the journey. The future is connected.